Okay, quick little Edpuzle here for the start of Unit 3. So this is only 4 lessons. Should go pretty quickly. 1 or 2 new formulas, maybe 3. But let's kind of start off with some just background information about circular motion. So what we're talking about in this unit in particular is uniform circular motion. The reason it's called uniform is because it's going at a constant speed. So this is not changing speed at all. It's just continuing. Like we talked about in the simulation lab, all that's changing is the direction. Now, what we're going to talk about, though, is if direction is changing, there has to be an acceleration because direction is a part of velocity. So to say the direction changes in a velocity is to say that velocity is changing. And so there's an acceleration. So what we call this acceleration is the centripetal acceleration. This is an acceleration that points to the center of the circular path, or in particular, to the center of whatever is causing the rotation. When we talk about orbits are not circular. A lot of times they're going to say a circular orbit, and that's not true in real life, but it makes it simple for us. So it is to the center of whatever is causing that rotation. Just a few other little vocabs to review here as well is the word trajectory. If you don't know the word trajectory, that just means the path an object follows. So they talk about the trajectory of an object. It's the circular path it follows. Because it's a circle, we need to talk about the radius of that circle, which is the distance from the center to the circumference itself. And again, this is little r, right? So we know in a circle, there's my center right there. So my radius goes from about there at the center to the outside. There's my radius, right? Circumference as well we need to know because that is the total distance an object would travel in a complete circle. Do we remember the formula for circumference of a circle? If not, we're going to write it down. It is C equals 2 pi r. Pi r squared is the area of a circle. Be careful. We don't care about area of a circle right now. That doesn't matter to the pathway. Occasionally, you will hear them as well talk about an arc. An arc is just a portion of the circumference. So obviously, one circumference is a full circle. An arc would be like if I just traveled from like here to here, we'd call that an arc. It's just a portion of the circumference, not the whole circumference. Okay, a couple more things, which is why we're doing this as a puzzle, all this upfront notes. So remember that the whole point of velocity vector is that it tells the direction of motion. The velocity vector is always tangent to the circle. Sorry, there was a basketball game last night. I was yelling again. I really shouldn't have. Anywho, tangent to the circle, which you guys saw in the simulation, and we've talked about before, right? Again, when I was swinging my keys around, if I let my keys go at any point, we would know the direction the keys would travel because it would be tangent to that circle. Because of that, this is also called the tangential velocity. So this is the actual speed within the circle, yeah? Now, again, because it has constant speed, little note here, guys, because this is a basic vocab. The definition of speed is the magnitude of velocity. Sorry, I got my little mouse here. If they ever talk about the magnitude of velocity, they're referring to speed because speed has no direction. It's just 5, it's just 10, or it's 2.2, whatever. That's how fast you're going, right? Now, because there's constant speed within the circle itself, there is no acceleration then along the pathway. I am not speeding up along my pathway. However, it is changing direction, constantly changing direction. And because velocity is a vector quantity, sorry, I forgot to fill that in there, that has both, what does it have? Magnitude and direction. Any vector quantity has both of these things. Acceleration is a vector. It has direction, right? Time is not a vector. Time only travels one way as far as we know. Mass is not a vector. Doesn't have direction, yeah. But acceleration, velocity do. So because it is changing direction, there must be an acceleration somewhere. Now we talked about that acceleration always points towards the center of the circle, and again, that's the centripetal acceleration. So to make this clear, in order for circular motion to even occur, in order to travel in a circle, there must be an acceleration that points to the center of the circle. Otherwise, the object will not travel in a circle. Again, we talked about, kind of bump it down here, we talked about in the simulation lab, if I'm looking at this point on the circle, there was an example of I'm trying to go in a circle, but I veer off path. Yeah, I veer off path from the circle. We talked about how in order to get back into the circle, if I want to get back in, so there's me getting back directly into the circle. I wanted to end up here, but instead I ended up here. There needed to be a force that points into the center of the circle. So putting this on a microscopic scale, there has to be a force that constantly pulls us towards the center of the circle. And again, the reason why we don't just fall into the circle is because even as we are being pulled into the center, we're moving this way, right? So what happens instead is we just travel in a circle, right? We don't get any closer to the center because as I'm pulled in, I'm moving downward. It makes a circle. I don't fall into the center. Now, to be clear, later we will learn about rotational acceleration, which does specifically refer to speeding up along the trajectory. So if I have a slow circle, going faster and faster and faster and faster, that's not what we're talking about in this unit. We are specifically talking about only centripetal acceleration, which does not cause the object to speed up. You want to make a note here. Do I have this on the note card? I kind of have it on the note card. So again, the important thing is centripetal acceleration does not cause the object to speed up. It only causes it to change direction. So with that, our last thing here, if you guys could grab your note card, this is the formula for centripetal acceleration. And you saw, again, in the lab that changing the velocity and changing the radius affected the acceleration. So this is exactly how it does. So this is the front of the note card. Again, the back is going to say the acceleration that points to the center of an object moving in a circle. Whatever the acceleration is pointing to the center, we call it centripetal acceleration. And again, the important thing is causes the velocity to change direction, but not magnitude, i.e. speed. So go ahead and copy this down, and then we will continue in class with this tomorrow.